Okay, live now. So I'll answer questions in chat relevant to the live stream. In the description, there's there's a write-up for today's topic. Let's go there. I believe the link is in the description. Should be. Let me check. If not, I'll add it after the stream. So let me check on my phone. Turn the sound off. Okay. Channel. And oops, I'm not used to the interface here on the phone. More. Yes, Quank XYZ Lisp game. Okay, so there's a write-up there. And let's go there. Quank. So I have I've abandoned GitHub IO. I've also abandoned Git. Okay, so today's topic, before I go to today's topic, I want to remind anyone who's joining or put them up to date about what these live streams are. And it's right here, creating a game in Common Lisp and C. The original intent is to participate in one of the Lisp game jams. I don't think I'm going to make Autumn Lisp Game Jam. Maybe next spring. There are 2 of them every year. I should probably provide a link. Well, they don't really have like a permanent link for all the jams. Anyways, the project. I'm writing a game in Common Lisp in C using CFFI so far. We have basic UI with graphics, sounds played asynchronously. Region-based memory management to store assets, and some supporting Lisp code. And this is the module package dependencies. So modules are in C, packages, modules are in Lisp. So the game was originally going to be a breakout game. I don't think so. I think that's very boring. I'm not sure what the game is going to be, but it's not going to be breakout. And so that depends on, through CFFI, sound, UI, little tiny package for colors, small package for geometry, and region-based memory management, stack alloc C. UI is xlib based with Cairo. Okay, so I have other posts here. You can navigate to those on through the current post. You go to other posts on the bottom. Okay, so what are we going to talk about today, and what are we going to do? Well, I'm going to talk about we'd like to escape the second dimension. I don't even know if the game is in a state that I can bring it up, but it's very, very two-dimensional. There's no 3 dimensions yet, and I want to get there. And so first thing I chose to do was to do very simple texture mapping to isometric. Okay. And specifically the kind of isometric, it's not pure isometric where this angle and the other angle are 30 degrees. It's a little bit different. Easier to work with if you use a pixel editor, easier to make 3D type of images, but what we would like to do today is, I'm not going to cover this. We would like to do a few experiments in C, mapping a two-dimensional texture such as, well, do I dare go to my desktop? So say like that, like this, mapping it to 3D, something like, say that, but not in that format. I already have a program in GTK that works, but I want to work with a modified version of my XLib code. The GTK version has, well, I don't like GTK because there's no message pump loop, so you're really not in control. It's GTK decide. You provide GTK with callbacks. Let's go here. Like right here, you set up your callbacks right here through Signal Connect, and whenever GTK feels like calling your function, it will give you a call. You know, each for each signal, each event, like draw or destroy or key press, it will call the whatever it will call whatever callback you provided. So I don't want to. I would like to use. I would like to use XLib because that has what's known as a message pump, and if we can find that here, this is what I'll be working with today. What do we have here? Well, this code doesn't even have a message pump loop. It just has a get next event, and it takes an XLib event and just returns some enum because that's easier to work with in Lisp. Okay, so let's go back here. Okay, so we're going to map these textures to isometric. Actually, not isometric. It's going to be dimetric, where the two angles, this angle, this is your horizontal, this angle, and the other angle on the other side are equal. Okay, and specifically, we're going to choose a slope of 0.5. And why? Well, let's take a look at this texture. View image, open image, and new tab. The reason is it's very easy to draw straight lines as long as they're aligned with your axis in 1 to 2 format. So 2 pixels here, then 1 pixel up, 2 pixels, 1 pixel up, 2 pixels, 1 pixel up, and so on. And that, if that were expanded, that would be a square. And if I were to draw more pixels here. Okay, so the angle between a line which lies along the y-axis as projected to the screen and the x-axis is approximately 1159 over 250 radians, which is in decimal, it's going to be 1159 divided by, I'm sorry, not 250, 2500. It's going to be 0.4636. Let's select 8 digits. Okay. Okay. And let's talk about angles for a second. Henceforth, angular units today and forever in all of my streams all angular units will be radians. The whole degree, minutes, seconds, or decimal degrees, those are a relic, and you have 360 degrees not because there's something magical about 360 degrees. It's because it was close to well, okay, I don't know the full history, so if I'm slightly incorrect, I apologize. The Babylonians loved base 60, so 360 over 60 is. I don't know what digits they used past. Well, I don't know what digit they used at all. So it's evenly divided. And 360 just happened to be really close to the number of days in a year. But it has no place in the modern world. So we're using radians. Every single function in every single programming language defaults, typically, almost, defaults to radians. For those of you who don't know what radians are, just know that 2 pi radians are equal to 360 degrees. Easy conversion. But I'm not even going to convert unless I have to take from some other source. But let's go through a quick definition of radians. Where did they come from? No, that's only going to distract us. But radians are more logical angular measurement. And it's really nice if you have some fraction times pi would be typically how it's written. But here, up here, I just have that number right there. Okay. Now, number 2 lies along the y-axis. This will be the topic of a future stream. But the current axis conventions in computer graphics are only the way they are for historical reasons. So I'm going to talk about our axis conventions in future streams. So first of all, the bold E with a little hat over it means a unit vector. Okay, so the x-axis direction, E hat sub x, is horizontal and positive to the right with respect to viewer, assuming that the camera or the viewing position isn't rotated. Isn't rotated. Z-axis direction, this is the most important one, is positive up. Now, typically in computer graphics, Z-axis, Y-axis is positive up with respect to the viewer. Typically that's Y-axis and it's inverted because that's the way it was. It had to do with the way hardware drew graphics. And the y-axis direction, okay, so there's our z, up. This is up, and this is someone's eyeball, and x is to the right, and you take the cross product of z and x, and you get y, or equivalently, z is a cross product of ex and ey, e sub x and e sub y. And this is absolutely the way things should be. To further make things confusing, when when computer graphics went from 2D to 3D, which I assume was very early on, someone somewhere decided not decided to keep the old screen system for X and Y, and what they did was they threw in a Z that, to keep the coordinate system right-handed, was like that. So Z was into the paper, into the screen, away from the viewer. This is why things like Z buffer have their name, because Z buffer is really depth and distance away from the viewer, things like that. We're not doing it that way. The first thing we're going to do is get everything straightened around and get out of that very confusing system, which, if you worked in, I don't work in computer graphics much. And to me it's confusing, but maybe to a professional graphics programmer it's not. Anything else I'd like to cover? Absolutely not. You can read the rest of the footnotes. Okay. So for texture mapping, we'd like to take this, not this. We'd like to take something that's flat and map it to this, specifically a flat on the ground, and the other transformations would be just as easy as what we're about to do now, or what I'm about to describe now. So, but one thing we can do, if we were lazy or programming, and I don't see why anybody would be this lazy, we could draw our textures directly in 1:2 format, which is 0.5, which is that angle with the projection horizontal. I say the surrounding blue is either transparent or color key. Well, we're not using color keys because Cairo handles PNG transparencies perfectly well. The main drawback of requiring all of our textures to be in 1:2 format is there are lots of flat ones in 2D, and there aren't as many 1:2s. So another approach is to use the built-in matrix transform of Cairo and just about any other graphics library to take two-dimensional textures to isometric format, as shown in Figure 3. And this is a unit square, and if our texture were a unit square, it would take it over to this form, and we'll get into all this other geometry in a second. We will take this approach when possible. Now there will, the way I see it right now, there will be some things that will be drawn in 1:2 format, maybe a spaceship or some things, because the code we're about to write or modify, I don't believe it would work well with this. And we'd have to come up with something more sophisticated. Okay, so set matrix. So we need to figure out what the transformation matrix we give to Cairo is first. And it's very simple. Control minus. Okay, so let's go to Control 0. Okay, so so what we're going to do is I've labeled these 4 points counterclock as P, Q, R, and S, and our transform will take P to P, and it has to take 0, 0 to 0, 0 in the transform space, and Q over here, which will be below P and to the right of P by these amounts. Oh yes, the sides of this square are length 1. And the same for R, okay, that's at 0 and 2 cosine alpha over. Alpha is our angle. We won't be specific just yet, but you know, in the end, it'll just be that, and so on. Okay, so this is what we have right here. So P 0, 0 gets taken to 0, 0. Q 0, 1, which is, I'm sorry, 1, 0, gets taken to, oh yes. Let C be the cosine of alpha, and let S be the sine of alpha. And we don't have to multiply those by the sides because the sides are length 1. Okay, so Q goes from 1, 0 to cosine C. That's these two sides are this length and this from here to here are the same. To minus S, so that's below P. R goes from 1, 1 to 2 times cosine alpha, and the y coordinate is 0, the transformed. And then S goes from 0, 1 to cosine alpha and sine alpha above. Okay, so we need to find transform matrix. It's just we'll let I, J, K, and M be our unknowns in the matrix. So so if we take point Q and see what happens, multiply 1, 0 by the unknowns, we get I is cosine and K is minus sine. Perfect. And then we try point R. So we substitute in for I, we substitute cosine, and for K we substitute minus sine. And we multiply that by 0.11 when we come out with, I'm sorry, R? Yes, we should come out with 2 times cosine and 0 for y. And just solving those two, we get J equals cosine and M equals sine. So we're all done. And we can check. We can just substitute everything in for I, J, K, and M and multiply by 0.01 to see if we get cosine and sine, and we do. Okay, and it checks out. And so for a 1 to 2 diametric projection, you just set alpha equal to this, which we talked about earlier. We have some test code in GTK3. I'll show it to you. It's a little bit buggy. It's just test code. But the crux of everything is the paint procedure, and what this does is it sets our matrix, which we talked about before, except this element and this element, well, they have to be transposed. Why? It's because of this, because y is down. There's a little bit of translation here. And so what we do is we just set once we set the matrix. We paint the background. Then we set the transform matrix, and then we have an image which we're moving around. And that will be transformed by this, but not the background won't. And then we draw a rectangle, and the reason we draw a rectangle around it in the transformed way is because we want to clip outside of it, and so we call Cairo clip, paint everything, and the result is something like this. What do we call this? Is it dim? I believe so. The result is something like this. So that's just a black and white image that, well, we can bring this up. Okay. And don't worry about this. And so what is the image? So the original image is the original image is, where are you? Not this. It's a PNG. Is it a list? It's called blue, but it's not really blue. There it is. It's just black with a transparent square. So if we were to change, maybe use that would be very simple. We just, instead of loading blue, I'll explain this shortly. Pile. Okay, and so you can see that this image has been transformed. And the reason we have the white is because that's not transparent. Now, if we were to go into a graphics editor, which that would be kind of interesting to do. Let's do that. And this movement, which is jerky, that's also one of the reasons why I want to try XLib. Is because I have to rely on a timer callback to move everything. So let's close that out. And we could also, instead of polka dots, we could say, what, sci-fi? Compile. That might be more interesting. On XP shell. And yeah. So before we do anything real here, let's just make the white background on this transparent. It's a very important feature because, to me, because bring a paintbrush, paint. No. In Windows, not Bash. Paint. View, zoom in, zoom out. Okay, so let's say that I'm going to draw some grid lines here. And let's just say we have some sort of spaceship, like so. We've drawn it, or whatever. I don't know. Pretend that's a spaceship. Outside of the ship itself, we can't. We don't want. Well, let's do this. Let's say there's a background there. Outside of the spaceship, we don't want, we do not want, what don't we want? We don't want the rectangular area to be whatever the background is, and let's just pretend that it's, let's pretend the background's, I don't know, blue, right? And so we don't want that background showing up like that. We just want the spaceship. So this should be transparent. We don't have color keying either, so we don't need it. So let's just play with it for a minute. Let's open this abomination, also known as GIMP. And while I'm waiting for that, let's see if there's anything interesting here. It's up on my other screen. 3 people. Wowee. Okay. And let's see. This thing will it navigate to my Ubuntu? No. Okay, so I'm going to have to copy stuff and bring it back, etc., but I'm going to do it anyways. So I'm working on WSL, and not every application works well with WSL. Surprisingly, GIMP is a Linux app, and it doesn't recognize my Ubuntu, my Linux drive, but it's whatever. It's just another data point illustrating how bad this program is. Funny though, all the Windows apps recognize, or everyone that I've used seems to recognize that drive. Okay, so it is going to be under projects, and the project is Diametric. I think I could call it Isometric. I think Diametric. Okay, Lisp logo PNG copy. Copy. And, well, we have to do it there because it's just, because we, yeah. So copy Lisp logo, paste. Paste. Okay, now we'll open it with this thing. Open, open. Desktop. Where are you? There. Okay, so I think what we can do here, getting sidetracked. This may be 2 streams. I mean, just my experience is that one stream isn't in general. So we'll just pull that out, and there will be a little bit of white feathering there, but I'm not going to worry about that just yet. Okay, and so the little checkerboard, that means nothing is there. Okay, so save, and yeah, no, not XCF. Boy, do I not like this program. Where is it? I have to say export, so it just doesn't save in the original format that you loaded. It really overwrite, okay? So it really wants you to save in its XCF format. Okay, and so let's copy here and go back to, just because we have to, go back here and then back here and then into the projects and then into Diametric. And just paste, replace. Now, okay, and we should be able to just run. And sure enough, there it is. And oh wow, look at that, it's transparent too. Nice looking. Okay, but it's in GTK, so it's fundamentally flawed. because fundamentally flawed, because for our purposes GTK won't work in the scheme of things. Okay, so let's all this code will be once it's complete, whether on or off stream, will be pushed up to I don't believe that do I say where it's going? Yes. Yeah, that's under today's agenda. Oh yeah, so let's talk about today's agenda. I'll move this test code to a copy of UI.c, which runs under xlib. The code for both GTK and xlib versions can be found in this repo. There's no license. Who's going to steal this? Who's going to make money off of it? I don't think anybody. This is the GTK version. Not that great, but it's test code. Okay, so where do we start? Well, we start, we start with our build script. No. And that's GTK. And what we want, I think, okay, this is xlib. So we're going to call it xdim. And why do we call this GTK gdim? Okay, output. We already have the code. I think. Okay. A few words about this UI.c. This code, being part of the main project, is compiled originally. Well, let's compare it with the original version. Can we do a diff? No, let's not do that. Okay, so F and projects, Lisp, game jams. We're going to change the name breakout, UI.c. So originally UI was meant to be a shared object. It has no main function, with some exported functions that could be called from Lisp. And we're just going to compile it and not worry, we could load it, as a shared object and grab all the function pointers and all that other stuff, but why not just stick a main in there and let it go with that? And that's what we're going to do. So what do we have here? We have a little program which, there's our message pump right there. We're not going to use X events. I don't think we need them here. We open a window of such size, 200 by 200. And while we don't return an event close, a close event, we just print the event name. We have some array somewhere with event names. But let's just compile that, and then we'll move on. So we're really just going to copy some code from the GTK version over here and adapt it to this. And that's going to be this stream and possibly the next stream. And then the next stream, we'll do a little bit with moving around in a smooth fashion. Okay. X, and it showed up over here on my other window because it felt like it. Yeah, okay, enter leave, button press, button release, key up, key down. end. Okay. And that's it. Great. Okay. I need a little screen that says I'll be back. I do feel like, how long have we been going? Let me see. It's already dinner time. Almost. How long have I been going? Looks like everybody got bored. That's okay. 40 minutes ago. Okay, well, let's keep going. All right, so this is the GTK version. So the first thing we need to do is we need to load some images, and we'll load them into a global variable. Load them into global variables. We'll call it background, and those will be GTK surfaces, and oops, Butterfingers. We'll call it G for global, G image, G background image, okay? And let's just see how we, here. I'm not going to do any error checking, I don't care. Let's make width and height. We'll make width and height. Does UI, what does it take? Okay. We'll default to 500, 500. Okay. Yeah, I've been having problems with and I apologize. I've been having problems with indentation ever since I've updated to Emacs 29, which I had to do for some reason, which I've long since forgotten, because it's a long string of things that I had to do some small thing, and then it leads to a triggering of cascading of other things. And that's not my formatting convention. And it's very, it's very, very, it's very, very unnerving, and it ruins my train of thought when things get moved around where I don't want them, where I don't expect them to go. So C, well, well, it claims that it's LMTEL. Boy, do I not like this. Because why did it throw that paren up there? Now it... Okay. Well, let's just get the images loaded, and then I'm going to terminate the stream because I can't work this way. When I don't like that thing just jumping up there. I went through great pains. That's my old style, or the way I don't call it my style, but I used to write it that way, and I had good reasons to put the brace on the same line as the if, but I have good reasons to not do that. Specifically, when I do matching, when I go Control-Alt-B, not there, Control-Alt-B, if it's in the same column, I know that it matched. Control-F. But if it's in a different column, it's like, okay, is that the right brace? So, so I decided to use a little extra space. But now Emacs has defeated me, and it has decided that even though I use the same style, it has decided, boy, do I not like this. I think this, when I first started Emacs many, many years ago, the very first thing that I did was turn off all this automatic, this electric. Is that what it's called? They call Emacs has this weird terminology, like it calls electric. Let's look at this. Once again, I'm sidetracked because I made the mistake of updating my Emacs because Emacs C mode, and we'll just type electric. I don't know why they call it electric. Why don't they just electric C? Toggle electric state. Okay, maybe that's it. How do I get the electric state? Can I even grab it? Oh, it's a function. Well, maybe I can do this. And what did it go to? Did it go turn it off? Did it turn it on? What was it? Messages. It's not going to bother to tell me. Okay. Just because. But let's see what happens. Oh, God. Are you kidding me? Well, sometimes I semi want the electric state, but I want the electric state that I had before, okay? I want things to go back to the way they were meant to be. And I need this stuff because it is impossible to... I don't need it so much for C as I do for Lisp, because try writing Lisp code without Emacs. You can't. And I'm not going to do something like this where I have to, no, it's going to be fixed. So I think I'm terminating the stream now because I can't write code like this, where my editor changes fundamental behavior, basic behavior every update. In ways that are unpredictable. Let's go to news. Message news. Let's see. No. Emacs. Let's find out if that was changed. So it went from Emacs 28 something to 29. Emacs 29 news. What's news? Well, that guy's not going to tell me. I want from the source. Nothing about electric, because I'm sure that none of this, there's no way I would use tree sitter, because I can guarantee you that if I use tree sitter, everything would be different. I don't see anything here. The new mode, pixel precision, well, let's take a look at that just because. Doesn't look any different to me. Okay. Look, I'll keep the stream on for 10 minutes. This is something that everyone who uses Emacs goes through this on a regular basis. And I'm not changing my behavior. So let's see what we got here. First of all, I have to remember what all these different styles. So if you go to, if you go here, if you go to the Emacs source, and I think I do have a Lisp source. There's like a list of styles, and that's a custom variable. And somewhere these are set. What's this? Oh, look. Here's a complete list of all the things you can set. See offsets A list, but those are offsets. I already need to change the behavior. Okay, so, oh God, look at all this. Okay, for those of you who, use something like Nano, which is probably the only sensible thing for C, here's the C styles. C indentation styles. And also, I had fixed this little problem yesterday or the day before, and now it reared its ugly head again. I won't get into indentation style. Okay, so here are the different styles. This is almond. This is what we want, basically. There's no way I'm doing this. Why do I have 2 levels of indentation? That's a little bit, I guess that's okay. Maybe. No, for reasons I just explained. Double no. That's not horrible, but whatever. I'm not going to say things like, oh, it looks weird, because I want want to be somewhat objective. This doesn't work for reasons that I explained. It's because you want braces to match up. And when you say match this brace, and it should just jump straight up, the cursor. And anybody who would code this way, yeah, that's just completely and totally wrong. You don't define your own language in C because other people and you have to read the code. Okay, so what are the types? So let's see, C, Emacs. Indenting C. Well, what styles do we have available? This is Wikipedia. This is like. I would like to read the rationale for this style. Actually, no, I wouldn't. Okay, so what are the styles we have? We have GNU, KNR, BSD, Whitesmith, Strostrup, LMTEL, and that was, LMTEL is like this style, almond, more or less. Linux, no. Whitesmith, is that here? User, when you want to define your own style, and that's exactly what I don't want to do. C, toggle auto state. Add the following: when you type certain characters, the new line will be inserted. But it does more than that. Or maybe that state. Let's see what happens. Maybe there's some toggle. Okay, so we'll pretend we just wrote that. We go down here, and then C, toggle auto new line. Boy, I would really not like that. Auto what? Auto state. Well, it doesn't even exist anymore. Okay. I don't mind that so much, I guess. Does it do the right thing there? I mean, I guess. Oh yeah, that's just totally wrong. That's no. And the thing is, I don't know what it's doing under the hood. See, and it's stressing my dog out. So I'm gonna go for a few more minutes. I don't know what I can't. I'm going to have to read the documentation to figure out why it decides to just jump that over there. Right? When I go, yeah. It's like, it's almost like, I go down here and then it's like, I can never go back up there and do anything again. Blah. Okay. See? Yeah, I don't like that. It's almost like I can never go back up there. If I hit enter there, I can't, no, there's no way I'm going to read the source code. So now I have something to fidget with for while I'm waiting for dinner. I'm going to cook dinner. I'll continue. I will continue the stream probably tomorrow. Thank you for watching. My apologies for 20 minutes of this, but let that be a I don't know what, a cautionary tale, whatever, about Emacs. What the hell? Cautionary tale about Emacs. It's very unfortunate because it takes years to set Emacs up to where you get used to it, where to where you can deal with it, and it's a real slap in the face for people to change behavior like that. Could be because of my config file, but I have recently changed my config file. But I'll figure it out, and I'll do another stream, and we'll write some real code instead of futzing with Emacs. So thanks for watching.